Okay, let's get this started. This is Josh. We'll be doing rational expressions and simplifying rational expressions for today's lesson. Okay, hopefully you've seen some of this stuff in the past when it comes to factoring square roots, but if not, I'll try to just do a little bit of review as we go through them so you can kind of see what needs to be done on all of these problems. Okay. The first one here I wrote down twice because I wanted to show two different ways of doing this. Our book shows one way, and then I want to show a different way as well. The book does this. Let's get all our factors of 80. Okay, so that's what you're going to be doing with all of these is you're going to be looking for factors that make some value. Now, before we do that, I guess we could also discuss the fact that anytime we have square root stuff, it can be busted apart or put back together. And what I mean by that is this. If we have square root 2 times square root 3, we can combine the two numbers and turn this into square root 6. So if I'm given a square root 6, can I bust that thing apart into two other factors? Yes, I can turn this into square root 2 times square root 3. The reason we're learning this or we're practicing this is because we want to take these math problems and we want to be able to cancel stuff out at a later time and then keep working with what we have left. If that doesn't make sense, just hold on, okay? So maybe if you need to, just kind of make sure you understand that we can do this. This is one of our rules that we're allowed to do with these problems. Now things change a little bit when you have a square root of 3 times a square root of 3. And again, you can try these in your calculator if you want. A square root of 3 times the square root of 3, well, what happens is you're kind of like canceling out the square root sign. So the square root of 3 times the square root of 3 is just equal to 3. Try it on your calculator, do square root of 3 times the square root of 3, and you'll end up getting a 3. All right? So that's just one more rule that we need to understand. And anytime we have two of something, or what I call doubles, then we pull those out of the problem and make them into a whole number. Again, if that seems kind of new, we've discussed it in class off and on throughout the year, how we can pull out doubles when we factor. So you might even want to check OneNote and see if there's a couple of those warm-ups where we did this as well. All right, so now that we've done that quick review, let's just get into this. Okay, the book has you do this. What are my factors of 80? I usually just go by 2s and 5s or 3s and factor this thing out. We have 2 and 40, and then we have square root of 2 and 20, and then we have square root, what's a 20? 2 and a 10, and then we have a 2 and a 5, okay? So essentially, what are my factors of this? I got this guy, this guy, this guy, this guy, and this guy, okay? So what the book does is it says, well, you have a square root of 2 times a square root of 2. So really what you're saying is you have a square root and then you have a 2 squared underneath. And what's happening is, and then you have another one here, which is a square root of 2 squared, right? Because I'm using 2 at a time. And then you have square root 5. The book is then saying, well, the square root sign cancels with the squared sign. And so essentially what you're ending up with is a 2. Multiply. The square root sign cancels out with the squared sign. And so you end up with a 2. And then you end up with times root 5. So once you have these numbers that are just whole numbers, you can combine them. 2 times 2 is 4. Square root 5, we just write it next to it, which means they're being multiplied, which they are because they're factors, right? These are all multiply. And this would be my final answer here, 4 square root 5. The part that I don't like about this is that they're making you take these two problems and like rework the problem again to show that it's going to cancel out. Let's do it again over here. What are my factors? I'll go a little bit quicker. I'm going to use the same ones. And maybe you're asking, well, Josh, what if I start with like 20 and, I don't know, 20 and 4 or something? Like, what if I have different numbers up here? The nice thing is when you factor this completely, no matter how you factor it down to the primes, you'll end up with the same answer. Let's see here, 2 and 20. I guess I should make my square root signs. Otherwise, it's bad form, right? 10. I know as students get faster at this, they stop writing all the square root signs, which be careful doing that because as we get more complicated stuff, it's good to leave the square root signs everywhere throughout this. I'll personally do it just to set an example, but at a certain point, you might just say, okay, I'm good. Okay, I know I'm going kind of quick, but we have a lot of stuff to do, and I want to make sure we go through all of these. Okay, so the other way you can look at it is, like I told you in the first part, where square root of 3 times the square root of 3 is just 3. So essentially what you're doing is you're pulling out any doubles. Okay, hopefully you're starting to remember this. We've done these before in class. Anytime you pull out a double from underneath the square root sign, because essentially all of these are like a whole bunch of square roots written next to each other. And so anytime we have a double, we pull it out from underneath the square root sign. And I have another double here, so I pull out another 2 outside the square root sign. And then what's left underneath the square root sign? Whatever numbers you still have left that you haven't used as a double just goes back underneath the square root sign, okay? In this situation, it's just a root 5. Combine like terms, and I get 4 root 5. For me, this makes a lot more sense to just say I'm going to pull out doubles rather than rewrite them as squared square roots, because it's almost like you're doing a little bit extra work here. But this is how the book's going to do it. This is another way you could phrase it to yourself, okay? Either way is fine. You're going to get the same answer. The main thing is to make sure that you keep your work nice and neat so that you know what all your factors are. I see students that just go crazy with this stuff and they're writing everything everywhere, and then they're not sure exactly like what are the final factors, like what are all these last numbers. And the reason I use these is because these are all the primes. 40 is not prime, so I had to keep going and split it. 20 is not prime, 10 is not prime. So I had to get it all the way down to these guys, then rewrite it as a simplified version. All right, let's keep going. Like I said, I know I'm going kind of quick, but we've practiced this before, and so even if you don't remember any of it, just follow along with the lesson. If you want to get started, you could probably at this point do this guy, maybe this guy, but not these two. All right, there's a little extra twist that goes with those bottom 2 problems. Now I have square root of 2 times square root of 14. Well, there's 2 ways you could do this. You could combine 2 and 14 and make it square root 28. The problem with that is it's almost like you're going forwards just to go backwards again. If I bust this guy apart, the first thing I'm going to do is pull out a 2, and now I'm right back where I started. So it doesn't really help you to combine all of this stuff, especially when these guys are already reduced to their lowest amount. Because now you're just continuing to keep on going, 2 and 7, and you're right back where you started essentially. Okay, but let's say I didn't do that, or let's say I didn't even know. Let's say I just said, you know what, Josh said multiply the number, so I did that. For some people, that's just how their brain works, and they're going to multiply this times this, and then just see what they get. And it's a big old number, and then they just divide it by 2, right? Use your calculator and just divide it all the way down. That's okay. It's not bad. I just feel like if you have a number that's already at its lowest amount, then focus on the other stuff and then just combine that with everything else. So, do I have any doubles? Yes, I do, because I had this guy as my final parts. So, I pull out my double out from underneath the square root sign. I have a 2. What's left underneath the square root sign? A 7. I circle my answer, and I'm done. All right, let's keep on going, shall we? We shall. This guy here was a little bit tricky, but I'll tell you what. If you tried it and didn't get it, that's okay. If you tried it and you want to get the hint, then listen up right now. The hint for this guy is you would do the numbers the same way you would do this guy. But anytime you have 2 of one of these X's, Y's, B's, whatever, if you have 2 of those, you can pull that out as well. Well, let's take a look and see what I mean. square root 90 x3 y4 z5. Okay, I'm going to work on the number first just because the letters are a little bit quicker. What makes a 90? 2, and 45. And what makes a 45? Again, it doesn't matter what numbers you use to create these. I'll do 3 and 15 just because why not? And then I have this guy here, which is another 3 and a 5. Okay, could I have done 9 times 5? Yes. And you would end up with a 3 and a 3 and a 5, right? Because 9 would be busted into 2 3s, and the 5 is just there. On a side note, if you're really understanding this, could I have also just taken the 45 here and done square root 9, square root 5? Square root of 9 is a perfect square, so I can just pull out a 3? Yes. And just be done and move on with the next part? Yes. If that part didn't make sense, don't worry about it, okay? But I know some of you guys might be thinking it through like that, and I know with some of you guys, we have discussed that that is allowed, because essentially you're doing it right here. These are all my parts. I'm just going to underline them just so I know what I'm working with. Are there any doubles? 2s? No. 3s? Yes. I can pull out a double of my 3s. And now I have some stuff that's left. Okay, I have a 2 and a 5, and of course, we already talked about that at the beginning of the lesson. If you have two numbers that are just kind of stuck there and they're factors, but you want to multiply them, just create your square root sign again and multiply them together. 3 root 10. Okay, now let's look at all of these guys, okay? I got three x's, right? Technically, it's x, x, x. Can I pull out a double? Yes. And if I pull out a double, then it's going here. Let me move that guy over just a little bit. It's going to go outside the square root sign, right? So I'm going to pull out a double, and I just write an x. What about my y's? I got y, 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 y. I got a double, so I can pull out a y. I got a double, so I can pull out a y. And now I got my z's. I got z, 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 z. I got a double, so I can pull out a z. I got a double, so I can pull out a z. And is there anything left? Yes. Let's see here. Okay, so before I do that, let's talk about what's out here. So I have 3x, y, y, z, z, and then square root 10, okay? So there's 2 steps you can do here. You can say to yourself, well, whatever's on the outside, I can combine like terms and make this into 3 and then x and then y squared and z squared square root 10. Then I can work on the stuff that's still underneath the square root sign because I still had a couple parts that just didn't get canceled. So I had the 2 and the 5, which is there as the 10. And do I have any x's or y's that were just kind of outliers? They weren't a double, so they're just kind of extra. Yes, I got that guy, which needs to come on down. And I got that guy, which also needs to come down, x and z. Okay, so at that point, this is a perfectly good answer. Some books will say, well, technically, you should have your letters with the highest exponent first. So you could have this written as 3y squared z squared, because it should be alphabetical order going with like the most x's or y's or whatevers. So it'd be 3y squared z squared, and then you would put the x in the back because it has less amount of exponents, right? It's just an x, whereas these ones are squared. So a more correct way to write the problem would be 3y squared z squared x, and then square root 10xz. Me personally, I think if you can get this far, if you can do all this awesome math and factor the number and then cancel out all the doubles of the letters, that's good enough for me, man. I would say this is full credit. If you put them in the right order or a different order, that's okay too. All right, that's the more proper way. But right now, if you're getting the main stuff from this, that is awesome. So great job. Now let's get into the fraction. I know we've done some of those before, but let me erase this. And if, like I said, if you want to move on ahead, try it on your own, go for it. If you want to do it with me, that's okay as well. All right. So I have the square root of 15. I guess it's like a really big square root sign. The square root of, oh, that's bad, 35. Okay, let's do this guy here. Now, we've talked a lot about this, and there's a rule in math which allows you to say, well, the square root of a fraction is the same thing as the square root of 15 over the square root of 35. Essentially, what you're doing is you're splitting the square root into each of these little parts. You're allowed to do this. And then from there, now you got to look at it and say, okay, well, can I do anything on the bottom? Well, maybe. Well, same thing with the top. It's kind of weird. Your goal when you're doing these, though, is very specific. Essentially, you're trying to get rid of your square roots on the bottom, okay? That's part of the rule, I guess you could say. In our book here, it lists it saying, let me read it, which expression is equivalent to this, and then they start working through the problem. Okay, so let's just do it together and make sure. Actually, that looks 35 over 15. It looks like I flipped it, so that's going to make it even more complicated. 35 over 15. Let me erase that and redo it. 35 over 15. This should have been flipped. So if you started doing that, I am so sorry. I did not mean to have that happen. Square root 15. Okay, there's a couple ways to do these. It really depends on what is going to be best for you. You could bust these into smaller parts and cancel. So let's do it that method. Use that method first. Square root of 35 is what? Square root of, what's a 35? Square root of 7 times the square root of 5 over square root of 3 times the square root of 5. Okay? So the first way we can do this is we can just bust these apart as much as we can into the factors. Well, and now we look at it and say, okay, well, because these are being multiplied, we're allowed to cancel stuff out of the top and bottom. A long time ago, we were doing those problems, remember, where it was like A times B times C over A times C? And we talked about how because these are being multiplied, whether they're numbers, letters, square roots, if they're being multiplied, we're allowed to cancel stuff out of the top and bottom equally. Well, this is the same thing, except for now we have square roots. So the first thing you need to do is cancel out the square root stuff and show what you have left. Okay, so now I have square root of 7 over square root of 3. And the way we get rid of a square root sign on the bottom is we just use this quick little trick, okay? We multiply the top and bottom by whatever is underneath that square root sign. Because remember, the rules of math say the square root of 3 times the square root of 3 is 3, right? We did that earlier, which is why I chose that problem. And then on the top, we have square root of 7 times the square root of 3. You can't do anything with it. All you can really do is combine the two numbers. So 7 times 3 is 21. I know your answer looks super weird because you're like, square root of 21 over 3, but that is the correct way to write it, okay? We were doing a chapter a while back that was like, no negative exponents on the bottom, right? You had to move everything up. Well, this is the same thing with square roots. You're not allowed to have a square root sign on the bottom because technically it's not a real number because it could go on forever. And so mathematicians decided we need to have a whole number of some sort or decimal on the bottom, but square roots on the top, totally legit. And so this is how we would work through it, is we would cancel out what we could and then keep on going. All right, let me move this guy over and show what the book did. So what the book did is it said square root 35 over square root 15. Well, this is a fraction that can be reduced. and they're both divisible by 5. So if they're both divisible by 5, then I end up with square root of 7 over square root of 3. Now I'm in the same spot as I was here. It's just that you had to recognize that they were both reducible by the same number. Okay, so if you notice that you can reduce it, then go for it, and then multiply both the top and bottom, square root of 3. These guys are going to turn into a 3. When you have a fraction, right? Again, this is why I love teaching pre-algebra and algebra, because the rules don't change. When you're multiplying two fractions, right? We got a fraction and a fraction. You just go straight across. Square root of 3 times the square root of 3 is 3. Square root of 7 times the square root of 3 is square root 21. Done. Right? That's my answer. Okay. So the next two kind of work together. Again, I know I'm going kind of quick, but I want to make sure that I get to all of these problems. The next two are a little bit different. And so let me do one. How about that? How about let me do one, and then if you want to watch and then try the next one. These two are pretty much the same thing. I just decided to do one with a plus, one with a minus, so that you could kind of see, like, is it the same thing? Yes, it is. Let's see here. We got 3 over 5 plus square root 2. Okay. I cannot cancel a 3 and a, let's say that was a 6, right? I can't cancel this and this, because this thing on the bottom is technically a quantity. It's technically a package deal. It's 5 plus some decimal number, right? If I used a calculator, that's what it would be. So I can't just cancel out of this because, one, because this is a part of something else, and then another telltale sign is that there's a plus sign here, not a multiply. If it was 5 times square root 2, and let's say I had a 5 up here, then yes, you could absolutely cancel that. Let's see how we do this, okay? In order to figure these out or solve these or get your square roots out of the bottom, we use this method called multiplying by the conjugate. And the conjugate is the same values that we have here, except for we're using the opposite sign. And so we multiply this by the conjugate, which is 5 minus square root 2, right? It's the same numbers, but instead of having a plus, we do minus. So if you're given a minus, you do a plus. Same thing. So hopefully after you see this, you're like, oh, dude, I can totally do that bottom problem. And what I multiply to the bottom, I do to the top. Now, once again, we have two fractions, right? We have fractions here. When we're multiplying, when we multiply fractions, I should say, you just go straight across. So and I guess if you want, you can even put these both in parentheses, because maybe that will remind you, oh yeah, I just distribute like that. 3 times 5 is 15. 3 times negative square root 2 is just negative 3 square root 2. Right? You can't do anything with it, so you just leave it like that. On the bottom, things get a little interesting when you FOIL, but again, think about why we learned all this stuff like 2 months ago, right? The whole FOIL method. If I have a plus minus with the same values, what's going to happen to the middle stuff? It's going to disappear. So I do, if you want, you can write it all out. That's fine too. We have FOIL. First is going to be 25. Inside and outside are going to cancel because it's 5 root 2 minus 5 root 2. So outside would be minus 5 root 2 plus 5 root 2, and then minus, right? Because it's negative square root 2 times positive square root 2 times negative square root 2 gives you a negative 2. All right. So that goes there. Okay. So the middles would disappear, and I end up with 25 minus 2. What's 25 minus 2? 23. And that's my final answer. Okay? So I know it looks like almost like we took a problem here and I just turned it into an even more complicated looking problem. But you were able to get rid of a square root sign on the bottom. And that's ultimately what your goal is. Because then you're going to take this math and continue to work through this doing other crazy math. We'll get to that on a different day, because right now this is already a lot. Okay, let me erase this stuff here, and get to that last problem. And like I said, if you've done this many or that one with the conjugate made sense and you want to try the next one and then pause the video and then see what you get, that would be fantastic. 5 over 2 minus square root 6. Okay, got to get the square root out of the bottom, got to simplify this thing. So I multiply the top and bottom by the conjugate. I have 2 plus square root 6, 2 plus square root 6, and now I just multiply 5 times that binomial. So I just distribute. 5 times 2 is 10. 5 times positive square root 6 is just 5 square root 6. Multiply on the bottom. We know it's a plus minus situation, so the middles are going to disappear. So let me just work on the outside. 2 times 2 is 4. Negative square root 6 times positive square root 6 is negative 6, right? When we have the same square root thing, the square roots cancel and we end up with just the number. Because I had a minus and a plus, a negative times a positive is negative. 4 minus 6 is negative 2. It's okay for you to leave a negative sign on the bottom with that whole number. That's great. Circle your answer and you're all set. Okay, so that was a lot of math. These are some new techniques, okay? This entire chapter, and I'm going to say this a lot of times, this entire chapter is playing with numbers, playing with rules that you're now learning, saying, hey, if you can factor this, can you then do this? Can you then turn it into this? That's what they want you to do. So think of it as one big game. Can I mix and match? Can I cancel? Can I pull stuff out? Can I multiply by things like that so that I can rework the problem? That's what this entire chapter is about. So if you're good at puzzles, if you like doing stuff like this, I know most of you are like, dude, I don't even like doing any of this. If you like doing this or if you want to follow along, that's exactly what I'm going to be doing for this entire chapter on rational expressions. Okay, so get to the work, try some of the problems, let me know if you have questions, and I will do my best to answer them right away.